Okay, so imagine you could take a brain scan of the exact same person twice. Once, the week before they wrote their first line of code ever, and then again 10 years later, after a full decade of professional programming. Same person, same genetics, roughly the same life circumstances, but the thing sitting inside their skull is not actually the same object, not physically, and that's genuinely a strange thing to sit with if you think about it for more than a second. Today, we're breaking down what a decade of coding actually does to the physical structure of a brain, not metaphorically, like, oh, it changes how you think. We've covered that angle before, actually, on this channel. Today's about the hardware, what 10 years of debugging and building and staring at a screen physically does to the thing doing the debugging. Let's start with the reveal, because there's a specific mechanism behind all of this, and it's got a name. Neuroplasticity, which, okay, you've probably heard the word thrown around a lot, sometimes kind of loosely, but the actual rigorous version of it is the brain's ability to physically reorganize its own structure in response to repeated, sustained mental effort. Not just new connections forming, though that's part of it. We're talking about measurable changes in gray matter density, in white matter, the wiring between regions, in how efficiently different parts of the brain talk to each other. And here's the thing that makes coding kind of a uniquely powerful trigger for this. Compared to, say, just general problem solving or general thinking hard, it's the combination of extreme precision and extremely fast feedback. Every single line either works or it throws an error. Right there, immediately. That tight loop, do something, get instant feedback, adjust, repeat thousands and thousands of times over years, is exactly the kind of repeated, effortful practice that neuroplasticity research keeps showing produces the strongest structural changes. So, where in the brain does this actually show up? There's a well-cited 2014 study out of the University of Passau that we've actually referenced before on this channel when we talked about what coding does to your brain more broadly, but there's a follow-up piece of that research worth sitting with specifically. So what the structural piece? Researchers comparing experienced programmers to non-programmers using MRI found measurable differences concentrated heavily in what's called the multiple demand network, which, think of it like the brain's general purpose problem-solving system. The same regions that light up when you're doing math or planning a complex task or holding several pieces of information in your head at once. In experienced programmers, this network doesn't just activate more, it shows structural differences, increased gray matter density in some of these regions, which, and this is the important part, is the same pattern researchers see in other domains that demand years of intense structured practice. Musicians, elite athletes, even London taxi drivers. Actually, there's a famous study on that one where the hippocampus, the memory region, physically grows larger the longer someone spends memorizing the city's street layout. Coding, it turns out, produces a similar signature, just in a different set of regions. Now, here's where it gets genuinely more interesting than the brain gets bigger in some spot, because size isn't really the main story here. There's a concept called white matter myelination. And okay, quick explanation. Neurons send signals down long fibers called axons, and those axons can get wrapped in a fatty insulating layer called myelin. More myelin means the signal travels faster and more efficiently down that specific pathway. Kind of like upgrading a dirt road to a paved highway. Same destination, way faster trip. Researchers studying skill acquisition have found that repeated, deliberate practice of a specific mental task increases myelination along the specific neural pathways used for that task, which means after years of coding, the actual physical wiring connecting the regions you use for, say, holding a complex system in working memory while simultaneously predicting what a function will output, that wiring gets faster. Literally, not metaphorically faster. The signal has less resistance moving through it. This is, honestly, part of why experienced programmers can hold what looks like an impossible amount of complexity in their head at once without it feeling effortful the way it would to a beginner. It's not that they have more raw processing power necessarily. The specific pathways they're using have been upgraded through thousands of hours of repetition. Okay, here's the myth-busting twist though, because I think this is the part that gets oversold constantly in pop science coverage of this topic. The popular version of this story goes something like, coding rewires your brain to be smarter, generally forever. And we've actually dug into this exact claim before in the Does Programming Make You Smarter video. The short version, that broad claim doesn't hold up nearly as well as the narrower, more specific one. What the structural evidence actually supports is highly specific use-dependent change, not a general brain upgrade. The multiple demand network gets more efficient for the kinds of tasks coding actually exercises, holding abstract systems in mind, predicting outputs, catching logical inconsistencies. It does not automatically make the language regions of your brain better at, say, writing poetry or reading someone's emotional state in a conversation, because those regions largely aren't the ones getting the repeated workout. And there's actually a slightly uncomfortable flip side to this worth being honest about. Neuroplasticity, it turns out, isn't a one-way street. It's use dependent in both directions. Pathways that get heavy, repeated use, get stronger, faster, more efficient. Pathways that go largely unused for years can actually show the opposite pattern, some reduction in efficiency or connectivity over time, which means, and this is the honest, complicated part, 10 years of intensely exercising one specific cognitive system might come with a quiet, gradual under-exercising of others. Not a deficit exactly, more like an underused muscle, the kind of thing we talked about actually in the engineering school video with empathy-based reasoning specifically. There's a physical piece here that's honestly less flattering than the your brain gets an upgrade story, and I think it's worth including because it'd be dishonest not to. Chronic, sustained cognitive load, the kind that comes with, say, sitting in a state of intense focus for hours, staring at a screen for years on end, has its own well-documented effects on the brain. Independent of the skill-specific gains, sustained stress and sustained sedentary focus are both linked in a fairly large body of research to measurable effects on regions tied to emotional regulation and sleep quality. This isn't unique to programmers. Specifically, it shows up across basically any intensely cognitive sedentary profession, but it's part of the honest picture. The brain that's gotten remarkably good at holding complex systems in mind is also a brain that's been sitting still under sustained mental load for a very long time. And that comes with its own separate set of trade-offs that have genuinely nothing to do with how smart you've become. So put all of this together, and here's the actual, honest, complicated picture. After years of coding, your brain has genuinely physically changed. Denser gray matter in specific problem-solving regions. Faster, more efficient white matter pathways. For the exact kind of abstract, systems-based reasoning coding demands constantly. That part is real, replicated, solid science. But it's not a general upgrade. It's a specific, use-dependent reshaping. Extremely good at what got exercised. Potentially, quietly, a little less exercised in the regions that didn't get the same repeated workout. And layered on top of all of that, the physical wear that comes with, just sitting, focusing intensely for a decade, which is its own separate story, that has nothing to do with code specifically at all. So go back to that hypothetical brain scan, same person, 10 years apart. The brain looking back at you in that second scan isn't smarter. Exactly. Not in some broad all-purpose sense. It's sharper, specifically at a narrow, powerful set of things, holding complexity, predicting failure, compressing chaos into structure. And it got there the same way any physical change happens, not in some single dramatic moment, but one debugged function, one late night, one small repeated act of focus at a time. Until 10 years later, the object doing the thinking isn't quite the same object it started as. If you've been coding for years, do you notice it? The specific way your brain works now compared to before you started? Tell me what's changed. In the comments, I'm genuinely curious what people notice from the inside.